So that was number 2. What other questions might you have come across that I could help you with from any of those?
Oh, so 8's the same thing then?
8, yeah, you're just putting D plus P in for the G one.
Okay.
So, but notice this.
Mm-hmm.
See how this stayed in parentheses?
Yes.
Just make sure if you're putting something in, it's always safe to keep it in parentheses.
Okay.
And you don't have to clean them up at all algebraically. You're not going to offend me. If you clean them up, it's fine, but I'm just saying. 7.
Did I end up just running with the decimals that I got out of Desmos?
Holy cow, you got decimals?
Yeah.
All right. So they tell us that f at x is 3x minus 1, and they tell us g at x is x squared plus 5x minus 7. So if we wanted to do g at x minus f at x, again, we can leave this dirty. So I'm going to take, this is g at x. So I'm going to have this. Okay? And then this minus sign is going to come right down here. But I'm going to put something in parentheses. And what I'm going to put in parentheses is this. And again, you can leave these unsimplified. I just call them, we're leaving them dirty. Some teachers might walk in here and roll their eyes. Why aren't they distributing a negative over the parentheses, combining like terms? Because I'm not requiring it. Now, it's up to you if you wanted to do it that way. That's fine, but that's your answer. Any other questions that you might have come across that I can help you with?
8.
Number 8. So number 8, we are using the g at x equation, which is this. And they want us to do g at d plus p. So that means I'm going to take this and plug it in for both those x's. And again, I'm just going to leave it. I'm not going to go work them out. I'm just going to leave it as is. And it's done. Is that okay? Now, I'll warn you in advance that answer is totally fine. But if you were in a different class, they would want you to have this. So they FOILed this out. And then plus 5d plus 5p minus 7. And then combine any like terms. So you have d squared plus 2dp plus, I guess that's simplified. So this is the multiplied version out of this, but right for this class, I'm totally happy and content with that kind of answer. Anything else I could help you with? Are we good in the hood? All right. So let me get my keyboard because I need to jump on Desmos. All right. I'm still going to be say on that page. Find all the exact values. Okay, let's see. All right. Taking a look at, say, like number 13 on that same page. They have 2, and they also have negative 1/2. And so what they want us to do is they want us to find the quadratic function that works with this. So you have to realize this is the same thing as saying x equals 2. This one is the same thing as x equals negative 1/2. This one I do want you to clean up a little bit. So the binomial that works with this one is going to be x minus 2. The binomial that works with this one, multiply both sides by 2. So I get 2x minus or equals negative 1. So this is going to give me 2x plus 1. And then FOIL this together. So you get x times 2x is 2x squared. X times 1x is 1x. Negative 2 times 2x is negative 4x. And negative 2 times 1 is negative 2. And then those are like terms, so we can combine those together. So I get 2x squared minus 3x minus 2. So 2. And there's your answer. That would be the quadratic that would result in 2 and negative 1/2 being our answers. Okay? Does that make sense? The toughest thing on that is clearing the denominator to make sure you're not doing x plus 1/2. Realize x plus 1/2, you wanted to have it be 2x plus 1. Okay? Simple enough? Hey, so on number 15 it says find all the zeros. So looking at number 15, they want us to find all the zeros. So they gave us that big old h at x equation. So talk to me. What should we do to start out finding the zeros of this? Yeah. Plug it into Desmos. Now, it's possible that we will only have one real zero, meaning you have one place where it'll cross the x-axis. You could have a wiggle there, which means you would have all three of your zeros taking place at the same time, at the same location. But let's see what Desmos has to offer. Oh, that's my Spanish. I want to get away from Spanish. All right, so they have h at x. We're just going to change h at x to y.
And do you have to put equals y?
If you have it equals to a variable, being the y value is going this way, vertically, it will do it correctly for you. It is possible it might give you some sort of solutions if you didn't, but I can't guarantee that it would.
It gives me the same answer if I put it equals y or if I just leave it.
Okay. So I would try and get into
The habit of it.
a habit of doing the y just in case
Okay.
Desmos gets goofy on us. All right. So we have this fancy dancy thing where this is the only place that 3 exists. That's our only answer. That is not a wiggle. That is a cross, because a wiggle should kind of like flatten out as it approaches the x-axis. So right now I have 1, 0. Okay, that is a real 0, meaning it's part of the real number system. So that means our other 2 zeros are more than likely not real numbers or imaginary numbers, or sometimes they might call them complex numbers. Okay, so I know that -3 is going to work. Okay, so let me jump back to my graph. I know -3 works. So I'm going to use my synthetic division. I have a 1 there, I have a 1 there. So I have 3, 2, 1, and 0. So I have 1, 1, -4, and 6. And we have to figure out how we're going to make this one work. Okay, the 1 comes straight down. 1 times -3 is -3. We add straight down, so that gives me -2. -2 times 3 is +6. Add straight down. -4 added to 6 is 2. 2 times -3 gives me -6. We get a 0 right here. Okay, that very end 0 means that -3 is indeed one of the solutions to the problem. Okay, but they want us to find all the zeros. So in the real number category, we have -3. That's one of our zeros. But then I have to realize, okay, originally this was x to the third, x to the second, x. That means that'll be x to the second, x plus 2. And when we get to this point, if we're looking for imaginary roots, we need to go to the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right. So we can go with this. Now, friends, do you remember Algebra 1 like a while back? Do you remember that you just weren't getting the right answer? Like you plugged in A, B, and C perfectly, but you just weren't getting the right answer. Okay? This is something that I so dislike about the quadratic formula. There are so many different places where you can make a sign error. Okay? So I want us to start getting away from the quadratic formula, because we could sit there and do 20 quadratic formula problems, and still most of the class is going to get 8 out of 10 of them incorrect. You have everything plugged in correctly. You made a sign error. Do you trust me? Have I led you astray yet? I have. You're nodding your head no. Okay. All right. can I show you how to solve something by completing the square? It's always the exact same motion, and it's a lot less likely to make a sign error. It's always done the same way. So do you trust me? Can I do it? Like, I don't know, sir, if you're a teacher, I hope you can do it. Well, me too, but we'll see. All right, so let me span down this a little bit, okay? So all I'm worried about is x squared minus 2x plus 2. X squared minus 2x plus 2. I'm going to set it equal to 0 because we're finding zeros. Agree? All right. First thing. Garcia, you're looking scared. You okay? Okay. First thing, every time when you're completing a square, move the constant to the other side. The constant is the number that does not have a letter attached to it. So I'm going to move it to the other side. If I moved positive 2x to the other side, I'm going to get negative 2. Seem okay so far? Kind of hard to make a sign error so far unless you copied something down incorrectly. Agree? All right. If this out front is a 1, this is going to work. If it's not a 1, we have a different step to show you. Okay, ready? I'm going to put a set of parentheses down here. Is this good so far? I'm going to put an X here. Whatever this sign is, comes straight down here. Friends, this is going to be some challenging math. You ready? What is half of 2? 1. What is 1 times 1?
1.
So I'm going to add 1, and I'm going to add 1. So if I took x minus 1 and I multiplied x minus 1 and I had it squared and I multiplied it out, I would wind up getting x squared minus 2x plus 1. Okay? Then on this side, I'm going to go negative 2 plus 1 is negative 1. Okay, and let me just stop there. Do you feel comfortable with the math I've just done? Okay? So, I have a quantity squared, so I'm going to take the square root of both sides. If we took the square root of both sides, who remembers algebra 2? What do we do if we took the square root of both sides? What do I have to put on the right side? Plus or minus. Very good. Okay, so the square root of x minus 1 quantity squared is just going to give me x minus 1. Okay? The square root of x minus 1 quantity squared is just x minus 1. Plus or minus. Does anybody remember what the square root of negative 1 is equal to? I. Very good. So now, when I see a little I with a tail on it like that, that means I had a square root of a negative number. So now I'm going to add 1 to both sides, so I get 1 plus or minus I. These are two complex roots. Okay? A complex number means it does not cross the x-axis in traditional formats. Okay? Now, can I show you something on completing the square? I'm going to take the most complex problem in the world, and I bet you'll follow me on the completing the square. And I'll write down on the side a list of the directions that we do with completing the square. Okay, ready? Let's say I had 7x squared plus 5x minus 3 equals 0. Okay? Factoring that would be a nightmare. Plugging that into the quadratic formula, there are so many places you're going to make a sign error. Do you feel comfortable with that? So I said the first thing that we want to do when completing the square, so this is the step-by-step on complete the square. Step 1, move constant. Constant is a number that doesn't have a letter attached to it. Make sense? So I'm going to do this first. So what did I do to move that negative 3 over? How did I move that negative 3 over? I just added it. I did the opposite. It was a negative 3, so I added 3 to both sides. So that The second step is still the exact same problem. It's just I move the constant over. Okay? Second step, divide everything by the x squared lead term. So friends, what is my x squared lead term? How much? 7. Okay? So I'm going to divide everything by 7. That okay so far? So this means this cancels. So I get x squared. 5 over 7 is still going to just remain 5 over 7. And it's going to equal 3 over 7. Okay? We got the F word up there. We got fraction. Agree? We're not going to be scared of fractions any longer because I'm sorry, how you learned fractions in elementary school, though you loved your elementary school teacher, they didn't give you justice by teaching you fractions the way I learned them. You want to know how, when I was in 4th grade, how Mrs. Patterson was trying to teach me fractions? It was always this. I was the kid like trying to do anything else but pay attention. It was like, okay, Chris, this is how we're going to add fractions. If you have 2/3 of one pizza left, and then you have 5/7 of another pizza left, what do you have? And I'd be like, lunch? No, Chris. You have this. And she was always referring to food. And it was always bad for me because I was always hungry. Okay? All right. Hey, does anybody see on the third step down how we kind of have a big space between 5/7 x and the equal sign? I do that on purpose. Okay, so watch this. If your friend's on their phone, tell them to just put it down for a moment. Okay, we're going to figure out a complete square. You ready? This is the easiest thing in the world, and they made it so dang complex when they tried to teach it to you in Algebra 2 that you hated it. But I'm going to show you how easy it is. Third step. Take half of x term. Okay, this means double the bottom. If I double the bottom of 5/7, what do I get?
5/14.
5/14 goes right here. I'm going to put x here. This sign has to match here. Okay? We've just completed the square. Now we have to fill in some blanks. We're going to add something to both sides. We have to keep it balanced. Okay, if I were to go 5/14 quantity squared, that means I have 5 times 5 on top, which is 25, and 14 times 14 on bottom, which is 196. Okay? That means this entire thing right here, if I FOILed this out, I would get what I have up above. Okay. I'm going to show you where your elementary teachers, though they were nice people, might have given you an injustice. It's simply how to add the fractions. Okay, ready? Now, we all probably knew, oh, let's figure out a common denominator. And then you're like, okay, what number does 7 and 196 both go into? I don't know. Maybe 7 works on, it goes into 196. It might, I don't know. But maybe it doesn't. Okay, you ready? Watch this. It is useful to have a calculator, especially with bigger numbers. So I'm going to go 3 times 196. So I'm going to get 588. Plus sign comes down. I'm going to go 7 times 25. Gives me 175. And then I just multiply the bottom. Get 1,372. Yeesh. I do it right? 7 times 196. I'm just making sure. 7 times 196. 1372. All right. So then on top I have 588 plus 175. So I'm going to get x plus 5/14 quantity squared equals 588 plus 175 is 763 over 1372. Root. Don't forget the plus minus. And then my answer becomes this. You guys got quiet. You're like, Stirrup, you are insane. Yeah, we knew that. Done. Okay, now, you might be able to, does everyone have a TI-84 graphing calculator with them?
Yes.
You do? Sweet. Will you do me a favor?
Let me get it out again, yeah.
Giddy up. I think I have one too, so let me see if mine will work too. You have that 763 over 732, 1372 written down?
This?
Yeah.
No, because I only have this book. I'll write it down later.
Okay.
I don't have room.
Will you do me a favor? Let me borrow your pencil real quick. Thanks. 763 over 1372. Thank you. I got it.
Answer?
Okay, so I just want to make sure you have the answer the same way I get the answer. All right, graphing calculator, where is it at? Oh, shoot. I don't have it on mine anymore. Where is mine? Who stole? Oh, there it is. No one stole it.
There's an app for it as well.
Yeah. I just get this. I haven't fired it up in a while, so it's going to be like, hey, it's out of date, pal. All right, you remember the whole reducing fractions thing? So 763 divided by 1372. Oops, 763 divided by 1372. Enter. Okay. Then you go to math, fraction, enter, and we get 109 over 96. Sweet. 109 over 196. 109 over 196. And I still have the square root of it. All I did was reduce the fraction. Friends, if you can read through my chicken scratch, I apologize. My computer's not working. What is the square root of 196? Close. Go one more.
14?
14, very good. So my answer is this. -5 plus or minus square root 109 over 14. That is my ugly answer. Now, friends, I'm telling you, the completing the square, and I will always, if we ever have something on a test that says completing square, I'll put on these boards the list by this part by part by part by part. But we'll work with them more, okay? But I just want to focus on completing the square. The last thing I want to show you is how do we find the domain of something? The domain is the x values. Okay? All right. Playing on Desmos. clear that. Let's say I had y equals the square root of x plus 7. Oops, x plus 7. Okay, so the domain is where it exists in the x direction. Okay, so friends, do you feel comfortable saying that the point -7, 0 is a point on this graph?
Yeah.
Okay, so tell me what the domain is. Remember, the domain, we go from the left to the right. So if I start from here, does our graph exist where my finger is?
No.
It starts existing here. Agree?
Yeah.
And it'll go forever to the right.
Yeah.
So what is this domain got to be?
Bracket -7, infinity parentheses.
Okay, and you said bracket, so I did y equals, I forgot what I put up there, x plus 7, okay, root x plus 7. So Desmos would show this graph doing something like this. Well, that's -7. So it's going to, our domain is going to go from -7, and I'm using a hard bracket because this point exists, and it's going to infinity. Okay? All right. Kind of keep that in mind when you're doing tonight's homework. So we are going to finish the page. We're going to finish the Algebra Review number 3. And I'd like you to do 11 through 14. And 19 through 20. And I'd like you to make sure you do A through E on 20. Desmos will be your buddy on this. Okay? Happy to help you through it.